Okay, number 1. Consider the figure below with the boy bullying his sister. So part A is just plug and chug, work. So work equals F D sine theta. And theta is 30 degrees. And everything is just given. So that's really easy. Next part, how much work is done by the gravitational force? So which way is the movement? This one's a little bit more conceptual. Movement is this way. And the angle theta in this work formula that we have is the angle between the movement and the force. The movement is that way. By the way, which way is the force? Gravity. Downward. So this is the force of gravity. And so if gravity is pointing downward, and the movement is to the right, then you end up with the angle is 90 degrees. And I wrote sine. I just realized cosine is the correct. So let me fix that right now. So got that fixed. Cosine. And so looking at the part B, the movement and the gravity are in exactly perpendicular directions, and so the gravity is doing nothing, which kind of makes sense because without friction, gravity just pushes down and the ground pushes up and nothing happens. So part C asks the speed after 30 meters, and this answers the question that I have, which is, what would all that work do anyway? And of course that work didn't just dissipate because there's no friction. The work went into making the cart go fast, and I imagine it's going to be an enormous speed, but I'm not actually going to plug in the numbers. You would be looking for, let's see, what is the speed? The work equals the amount of kinetic energy that you gave the object, the change in kinetic energy, which equals the initial was 0, right? So I'm just going to write KE final, and KE final is 1/2 mv squared final. And just for good measure, I'm going to write minus 0. That indicates that the initial minus 1/2 mv squared initial, and initial is 0, and so that's that. And so you set the two equal to each other, like so. 1/2 mv squared equals the FD cosine theta from before. Equals that, 1/2 mv squared. That's an arrow. So number 2. The units on this should actually be newtons per meter, by the way. So 820 newtons per meter is K, the spring constant. And again, should be able to just plug and chug. It's good to read the question to understand the concepts, but it is simply the potential energy stored in the spring equals 1/2 the spring constant times the displacement from equilibrium squared. So you have 0.1 equals 1/2 times the given K, 820 newtons per meter, times x squared, solve for x. Number 3. Oh my goodness. Oh, I thought it wasn't recording. So it is recording. Number 3. I'm going to do number 3. I'm having technical difficulties. Okay.